Welcome back to the video, and today we're going to solve some inverse Laplace, but this time we're going to use a partial fraction method. Okay, so first, this is our problem. So here we can take out here the s. So 5 over, this will become s squared minus s minus 6. Now we're going to simplify this further. So here you can see that this is actually equal to your s. So this is actually your s minus 3, s plus 2. Now, we have here now your partial fractions. In order to do this, so it's actually 5 all over s times your s minus 3, s plus 2 equal, so you have your a all over s plus your b all over your s minus 3 plus your c is s plus 2. Okay, from here we can use the com method by our teacher told us. Com method is like, so that we let a here, let a. So your a is equal to you, so you have to divide this from here. So we took out the s here, so what's left is 5 over s minus 3 times s plus 2, which for s is equal to 0, because here when we divide this by 0, everything will be 0. So this becomes your a, which is negative 5 over 6. Next, we have our b. So b here. So again, we cancel out the s minus 3, cancel out this out. What's left here is 5 over s plus 2. And we let s is equal to your, based on here at your b, which is 3. So the answer here is 1/3. Lastly, on your c, so we took out here the s plus 2. What's left is 5 over s times s plus 2, which if your s is equal to your, so this will be negative 2. So this is equal to your 1/2. Now based on what you have values here, we just like plug it in here. So you have here equal to your inverse Laplace of your a is negative 5 over 6 over s plus your b is 1/3 over s minus 3 plus 1/2 all over s plus 2. Now by just looking at it, we can solve it easily. So here, this is actually your constant when in inverse, so it's negative 5 over 6. Here we have here a shifting of 3, so it's a 1/3 e raised to 3t plus we have another shifting here, this time is negative 2, so it's 1/2 e raised to negative 2t. So this is your final answer for your letter A. Okay, now this is our letter B. Again, our first step is to try to simplify the denominator. So here we can simplify it as 2s over minus 3 all over. So we took out the s. So what's left is s squared minus 10s plus 25. And we can just simplify further, s minus 5 raised to 2. Now we have here a repeated distinct factor. So the formula here of the partial fraction for this is 2s minus 3 all over s minus 5 raised to 2 equal to your a is your s plus your b, which is this s minus 5 plus c, which containing your square. I'm gonna use the coefficient method. Okay, so coefficient meaning I have to divide everything by your denominator, which is s minus 5 raised to 2. So our new solution, our new equation is 2s minus 3. So here we have a, so I'll just expand this, s squared minus 10s plus 25. Here we got here plus b s squared minus 5s plus cs. Okay, start off, we can say let s is equal to 0. So we have here negative 3. So we plot everything that has s here. We have here equal to your 25a. And here this will become 0. So your a here is equal to your negative 3 over 25. This is our first variable. Next one, we can have here s equal to your 5. So here we plot here, we have here 7 equal. We plot this actually become 0. So this is out. This one will also become 0. What's left here is your 5c. So your c here is equal to your 7 over 5. This is your second. On the last variable, we can say at b. So you're basing on your b. Here we have here 0 equals to your, you have here a negative 3 over 25 plus b. We are basing here your s squared. Okay, now your b is equal to your 3 over 25. Okay, now your final answer, or your final partial fraction is inverse Laplace of your, here we have negative 3 over 5 all over s plus your b now is 3 over 25 all over s minus 5 plus your c is 7 over 5 all over your s minus 5 raised to 2. Now by just looking at it, this is actually your constant. This is already your shifting, which is 5, and here we have here your t, and also a shifting of 5. So just straight to it. So it's 3 over 25, negative 3 over 25 plus you have 3 over 25 times your e raised to 5t plus 7 over 5. This becomes e raised to 5t times your t. So this is your final answer for your letter B. Next problem, we have your s squared minus 1 over s4 plus 16 s squared. Again, our first rule of thumb is to simplify the denominator if possible. So you have s squared minus 1 all over, this will be s squared plus s squared plus 16. Now this is actually your repeated distinct factors again. So we have your s squared minus 1 all over your s squared times s squared plus 16 equal to your a all over your s plus b all over your s squared plus, oh, this is not a repeated but a quadratic, plus with your repeated somehow. So here we have here dc plus c all over your s squared plus 16. Okay, now I will do is the coefficient method. So again, we have multiplied this by your denominator. So what's left here is s squared minus 1 equals to your a times your, so you have here s cubed plus 16s plus your b is s squared plus 16 plus we have here ds cubed plus cs squared. You don't see it, I'll just type plus cs squared. So first we will let s equal to 0. So here we have negative 1 equal, so it's here cast on s, you have here the b 16b. So your b is equal to 1 over negative 16. This will be your first variable. Next, I'll try to find the coefficients. My meaning by this. So at s cubed, so here no s cubed, so 0. Here we have a, we have none, but we have here plus d. Okay, next we have here at s squared. So here I have 1. Now here we have here none, but your b, you have s squared, so your b here is negative 1 over 16 and plus c. So meaning your c here is equal to your 17 over 16. Now let's have here at s. So 0. Here we have here your a, so this is a. Next, so there's none, meaning your a here is 0, but we all know that this one is also 0, meaning your d here is also equal to 0. Okay, now to simplify this, so your a is equal to 0, your b is negative 1 over 16, your c is 17 over 16, and your d is equal to your 0. So we're gonna plot it in. Okay, now we have it here. So let's plot it in. So since your 0 is a, so this cancel out. Your d's cancel out, so 0, 0. What's left here is your inverse Laplace of your negative 1 over 16 all over s squared plus c here is 17 over 16 all over s squared plus 16. Let me put it in a big parenthesis. Now, as we can see here that this is already your t, or a step function. And here we notice it is also a sine function. By just looking at it, this will be pretty easy. So this is actually t all over 16 negative plus, so we took out the 17 here, 17 over 16. Since this is 4, your b is 4, so we have to multiply this by 4, meaning we have to divide this by 4 also. So this will be your sine 4t. Here, this is to be simplified, this will become your 64. This will be your final answer for your letter C. This is our last letter. So we have 3s minus 5 all over s times s squared minus 2s plus 5. Now, first step is to simplify. Since there's no simplified, let's continue on. So this is actually your quadratic function or quadratic factoring. Okay, now let's have here as 3s minus 5 all over s times s squared minus 2s plus 5 equal to your a over s plus b s plus c all over s squared minus 2s plus 5. Okay, again, what I did is another method is the coefficients. So we divide this by your denominator, and here is your new formula. 3s minus 5 equals to your a times s squared minus 2s plus 5 plus b s squared plus cs. Next, I'll let s is equal to 0. So we have here negative 5. Here we have here equals to 5a. So your a now is equal to negative 1. So let's start on with a coefficients. So at s squared. So your s squared here is 0. Your a here is negative 1. Next we have here plus b. So your b here is equal to your 1. Next we have here at s. So you have here 3 equals, so this is your negative 2 times your negative 1. Then there's plus c. So this will become 2 transferred to the other side. So your c is equal to 1. Now we have here the variables. So we just place it here. So equals to inverse Laplace of your a negative 1 over s plus 1 all over your s squared minus 2s plus 5. Now by looking at this is already your constant. So this will be your negative 1. So let's simplify this. So this is actually s squared minus 2s plus 1 plus 5 minus 1, since we took out the 5 here and we tried to complete the square. So this is actually 4 plus 4. We simplify this, so this is s plus minus 1 squared plus 4. Now by looking at this, we are dealing with a sine function. But since in our top here is plus 1, it should be equal to your s down here. So we manipulate this. This become your minus 1 plus 2. Okay, let me change this. Minus 1 plus 2. This will be bracket. Okay, now we have here 1 over s plus we have a s minus 1. So by using linearity properties, we have here inverse Laplace of your negative 1 over s plus inverse Laplace of your s minus 1 over s minus 1 raised to 2 plus 4 plus this will be your inverse Laplace of your 2 all over s minus 1 raised to 2 plus 4. So by just looking at this, our final answer is negative 1 plus we have here 1/2 because of your 2 here, your b is 2, 1/2 e because of the shifting, e raised to t. Now this become your cos of your 2t plus, since we have a 2 here, so don't need to put 1/2 outside because this will cancel out. So what's left here is e raised to t times sine of your 2t. Today I learned the inverse Laplace transformation by using the partial fractions. And it's very easy because you have to manipulate the denominator and also find the sequence form in order to use the partial fractions. Thank you for watching and see you in the next video.